In the realm of science and cosmic mysteries, the question of what existed before the Big Bang has stirred debates and intrigued minds for centuries. This profound question doesn't just challenge our understanding of the universe. It challenges the very boundaries of human knowledge. Imagine standing at the edge of existence, staring into the vast darkness, and wondering what lay there before our universe was born. The moment of the Big Bang marked the beginning of time, space, and everything we know, but was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic orchestra began? And if so, what was it? Or perhaps, was there something far more terrifying that existed before time itself? As we dive deeper into this question, science takes us on a journey beyond the universe's origin into concepts that defy our understanding. Physicist Brian Cox, known for his exploration into the wonders of the universe, suggests that something terrifying might have existed before the Big Bang. He challenges us to rethink our concept of reality, time, and space. In this exploration, we'll delve into the science, the theories, and the jaw-dropping mysteries that might explain what existed before everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered might just shock you, but they could also unlock new understandings of our place in the cosmos. Get ready to dive deep into a world beyond imagination and science, where the unknown still looms in the shadows, leaving scientists astounded and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to carefully examine what the Big Bang actually was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to set off the creation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot, beginning with galaxies spreading out in all directions from a central point. But why did this happen, and was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything that would follow. In a fraction of a second, space stretched at speeds beyond comprehension until the expansion slowed and the energy transformed into matter, particles, and the four forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly inflate the universe, and why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming here and there. Each bubble represents a universe, including ours. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with the question: what else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still create new forms of energy. This fact alone is baffling to scientists, as it suggests that true nothingness might be impossible within our cosmic understanding. As we probe deeper, we find that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, and no energy, but quantum fields and fundamental constants still exist, meaning that this nothingness has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a ghostly echo of activity even in what should be empty space. This defies our concept of a true void and suggests that, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the idea of eternal inflation. If inflation could cause our universe to exist, it's possible it could continue on indefinitely. Brian Cox describes a terrifyingly vast inflationary multiverse, where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting a new universe, while inflation persists in other areas, creating countless other universes. This process could, in theory, go on forever. This idea of infinite universes gives birth to a fascinating concept of a fractal universe, where every new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an endless multiverse with no ultimate beginning or end. What if our universe is just one speck in a colossal cosmic structure, expanding and creating forever? And what if the terrifying truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Instead, it's a network of energy fields that fill the cosmos, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as ripples, waves, or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, borrowing energy temporarily before returning it. This phenomenon gives rise to virtual particles, entities that briefly exist and then vanish, leaving behind a faint memory of their presence. The concept of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have complete nothingness? According to quantum field theory, you would not. Even in a vacuum, fields would remain active, occasionally producing fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't understand our concept of emptiness. The fields and forces persist, filling the universe with an underlying energy that prevents absolute nothingness. This insight raises an intriguing question. If fields create particles and particles create matter, then could the universe itself have emerged from this nothingness, filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to scientists, it's possible that the dark energy we observe today is a remnant of an energy field from before our universe's formation. Dark energy's properties seem to suggest a vast hidden power that could have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, could have powered the inflationary phase, allowing for rapid expansion. The presence of dark energy implies that even if our universe were emptied of all matter and radiation, this force would continue to stretch the fabric of space-time. This idea leads to an unsettling thought. If dark energy was present before the Big Bang, it might have shaped the conditions that led to the birth of our universe. Could dark energy be the silent architect of cosmic inflation, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy not only as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but rather part of a cosmic rhythm, where universes expand, collapse, and then re-expand in a new cycle. This theory proposes that our universe might have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but instead an infinite sequence of universes emerging, evolving, and renewing themselves over and over. Cyclic cosmology raises profound questions about time, as it suggests that time itself might be circular rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, This theory offers an elegant solution to the question of an ultimate beginning by suggesting that there isn't one. Instead, the cosmos has always existed in one form or another, transcending our notions of time and existence. Primordial gravitational waves are another fascinating concept that might hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that primordial waves, if detected, could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what happened during the first fraction of a second after the Big Bang. But what if there were waves that predate even the Big Bang? Some theories propose that gravitational waves could exist from the collision of universes in a multiverse, or from events that occurred before the birth of our own universe. These waves would be a haunting reminder that the universe itself may have had a complex, layered history long before the Big Bang. As we conclude this exploration, it becomes clear that the mysteries of the universe's origin are far from solved. The theories surrounding the question of what came before the Big Bang reveal a vast, complex reality that pushes the boundaries of science and human imagination. From cosmic inflation and multiverses to quantum fields and dark energy, we are beginning to grasp ideas that challenge everything we thought we knew about time, space, and existence. While we may never fully answer the question of what existed before the Big Bang, these theories offer a glimpse into a universe that is far stranger and more terrifying than we could ever imagine. The quest to understand the nature of nothingness, or the eternal cycle of creation, remains one of the greatest challenges in science, but it's a journey we are only beginning to take. As we continue exploring the question of what existed before the Big Bang, we must delve deeper into the speculative realms of physics and cosmology, where traditional concepts of space, time, and causality break down. One intriguing idea that has emerged from theoretical physics is the concept of a quantum vacuum state. This theory suggests that even in the most seemingly empty space, quantum fields are never truly at rest. Instead, they fluctuate constantly, giving rise to spontaneous events such as the creation of virtual particles that momentarily pop into existence before disappearing. These fluctuations imply that the very fabric of reality is never still, even in the absence of matter and energy. It challenges our understanding of nothingness and opens up the possibility that the universe we see today could have emerged from a similar quantum fluctuation, a spontaneous event driven by the inherent properties of quantum fields. Furthermore, quantum gravity, an area of theoretical physics that seeks to reconcile quantum mechanics and general relativity, provides another layer of insight into the mysteries of the pre-Big Bang era. One possible outcome of quantum gravity is the idea of a quantum bounce. In this model, instead of the universe starting from an infinitely small singularity, it could have undergone a transition from a contracting universe to an expanding one. The universe would have contracted down to a very dense state, but rather than collapsing into a singularity, it would have experienced a quantum bounce, leading to the expansion we observe today. This suggests that the Big Bang might not have been the beginning, but rather the point at which a previous universe's collapse transitioned into a new phase of expansion. This cycle of contraction and expansion could potentially be eternal, with no true beginning or end to the cosmos. Another fascinating idea comes from string theory, which posits that the fundamental building blocks of the universe are not particles, but rather tiny vibrating strings. These strings can vibrate in different patterns, creating the particles and forces that make up our universe. In string theory, there's a possibility that the universe we know is just one of many brains floating in a higher dimensional space. These brains could collide and interact with each other, leading to the creation of new universes. The Big Bang, in this context, could be the result of the collision between two such brains. This model, known as the brain world theory, suggests that the Big Bang wasn't the beginning of all things, but rather a cosmic event triggered by interactions within a multidimensional landscape. If this is the case, then the question of what existed before the Big Bang becomes even more complex, as it may not just involve the history of our universe, but the histories of many others. As we consider these theories, it becomes clear that the notion of before the Big Bang is not as straightforward as we might think. In classical physics, the idea of before is tied to the concept of time, which began with the Big Bang. However, in the realm of quantum mechanics and string theory, time itself may not behave in the way we perceive it. Some physicists propose that time, as we understand it, could be an emergent property of the universe, rather than a fundamental aspect of reality. If time emerged with the Big Bang, it's possible that there was no before in any meaningful sense. This could fundamentally alter how we think about causality and the flow of time itself, making the question of what existed before the Big Bang even more elusive. Additionally, the concept of dark energy, a mysterious force driving the accelerated expansion of the universe, could hold the key to understanding the pre-Big Bang state. Some researchers speculate that dark energy was present before the Big Bang, and its properties may have influenced the conditions that allowed the universe to emerge. Dark energy's potential to influence cosmic inflation means that it could have played a crucial role in the transition from a pre-Big Bang state to the observable universe. In this framework, dark energy might not just be a feature of our current universe but a leftover force from an earlier cosmic epoch, suggesting that the forces that governed the early universe might have been far more complex than we realize.